All right, let's talk about eclipses and tides. So, eclipses are when the moon is actually in shadow or the moon is shadowing something else. They're a little bit different than your regular moon phases. So, if you look at this diagram here, this is a view from out in space if we were beside our solar system looking in. And obviously, this isn't to scale, but you see the Earth here and you see how the moon is orbiting. Notice that the moon does not orbit us like in a straight parallel line, it's tilted. And that tilt is the reason why eclipses don't happen every single month. So, there are two types of shadows. For example, if this is a light source, this is an object blocking that light source, you have two different types. You have the penumbra, which is this lighter outer shadow. It's on both sides. And then you have the umbra, which is the darker inner shadow. So this shadow is going to be a lot darker. These are a little bit lighter. And I remember it by imagining an umbrella. You hold an umbrella right above you and you're protected from rain and elements and so forth. So you can remember that the umbra protects you from all of the light over here. All right, so with a solar eclipse, let me go back to this. All right, so the sun in this diagram would be over here on the side. You can see that the umbra and the penumbra are labeled here. A solar eclipse is when the moon blocks out the sun from Earth's perspective. So this would only happen in a new moon phase because you see that the sun would be over here, moon's right here. The reason that this is different from a regular new moon is because the moon is going to fall in that specific angle to block out the sun from Earth's perspective. So if I'm a little person standing on the Earth where my arrow is, I am in the umbra shadow. And if I am in this umbra shadow, then I would see the total solar eclipse. I would see the sun completely blocked out. Now, if I am just standing in the penumbra, I would see only part of the sun blocked out. So, you guys see this little line here? This line is called the path of totality. The moon does not cast a very big shadow on the Earth. Keep in mind that this diagram is not to scale, and the moon in reality is a lot farther away and a lot smaller. So this little shadow that the moon creates is not that big, which is why you have to be standing directly in this shadow in order to see the eclipse. If I'm over here in Antarctica or whatever that is, I would not be in the shadow, so I would not see a solar eclipse. I have to be not only on the daytime side of Earth, but I have to be in the path of totality to see the total solar eclipse. And if I'm in the penumbra, then I see a partial solar eclipse. So this is what the partial solar eclipse would look like. You can see that just a little part of it is blocked out. Also, note to self, never ever look at a solar eclipse without the special glasses because it will still burn your eyeballs. This is what a total solar eclipse would look like. You can see the corona outside of the sun here, and this light part here is what burns your eyeballs if you look at it. So never look at it without the special glasses. But again, this is what you would see if you were standing in the umbra shadow in the path of totality. Alright, so here's another diagram. This one's a little bit better. Sun is over here. You have the umbra, penumbra. You see the moon blocking out that little shadow on Earth, and you would have to be on the daytime side and in this path of totality in order to see the total solar eclipse. And again, it can only happen during a new moon phase. Oh, I'm gonna go back to that. That's what it would look like if you saw one all nice and sped up. They're pretty. All right, this is the one that we had a couple years ago. This is where the path of totality was. So if you were anywhere in this path back in 2017, then you would have been able to see the total solar eclipse. I was in Georgia over here-ish, so I only saw the partial solar eclipse, but it was still cool. And this is the one that is happening in 2024, so we are right in there, so you lucky us. All right, so let's talk about a lunar eclipse. Let me find it. All right, this is the best diagram. All right, so with a lunar eclipse, again, your sun is over here on the left side. With a lunar eclipse, your moon is going to fall in the Earth's shadow instead of the moon casting its own shadow. So you still have the umbra and the penumbra here. You can see that the umbra and the penumbra basically cover all of the nighttime side of Earth. And that the shadows are a lot bigger. This is because the Earth is a lot bigger. So in this case, if the moon is in the umbra, we will see a total lunar eclipse. If the moon is in the penumbra, we will see a partial lunar eclipse. And the cool thing about lunar eclipses is that you see how this moon is a little red here? That's actually what they look like in real life. They're also called blood moons. So what happens is if you remember, right here on the Earth is spinning this way. So right here, you're going from day into night, which is sunset. And then up here, you're going from night into day, which is sunrise. And what color is the sky during a sunrise or sunset? It's the reddish orange pretty color. The reason this happens is because when the sunlight hits these two parts of our atmosphere, it bends, and when light bends, it changes into different colors, which is why you see sunrise and sunsets as those pretty orange red colors. And now during a lunar eclipse, that light is all projected onto the moon, so you are basically seeing every single sunrise and sunset in the world happening at the same exact time. So it's really cool. This is kind of what they look like. They're really pretty. And again, for a total eclipse, the moon has to fall in the umbra shadow. For a partial, the moon would have to be in the penumbra shadow. And the cool thing about these is that if you are anywhere on the nighttime side of Earth, you will be able to see it because the shadows cover up the entire nighttime side of Earth. Alright, so now let's talk about tides. So tides have everything to do with the moon and with gravity. So whenever, basically, if you look at all the patterns, wherever the moon is, you're going to have your tides facing the moon because the moon is pulling on our waters. So, So if you look at this diagram here, the moon is over here. We can see that the high tides are right here and right here where A and C are. If the moon was up here where my arrow is, then the tides would be here and here. This is why we have 2 high tides and 2 low tides a day. So let's say I'm a person on the Earth right here. As the Earth is spinning, I have a high tide right here. About 6 hours later, I'm here, which is a low tide. 6 hours later, I'm here with the high tide again. And then 6 hours later, I'm with low tide, and then so on and so forth. So that's why we have 2 of each per day. And as the moon slowly revolves around us, the high tides and low tides will change their location. So, again, remember, the high tides are always parallel to the moon in that straight 180-degree line. The low tides are at right angles at all times. And again, we have 2 high and 2 low every day. And there are also 2 different types of special tides that happen. So you have spring tides. This is when you have a new moon or a full moon. Whenever you have a new moon or a full moon, the Earth, moon, and sun are in a straight line. So the sun would be over here. And when you add the sun into the equation, it can make the tides more extreme. So with your spring tides, your high tides will be higher than normal. Your low tides will be lower than normal. This is the time that you want to go to the beach and surf and search for seashells because the waves will be better. So again, 180 degrees, straight line, extreme tides, happens every new and full moon. Now with neap tides, you notice that the sun, earth, and moon are at a 90-degree angle. So, because same with low tides, whenever you have this, the sun and the moon are pulling in opposite directions, which makes the tides a lot more mild than normal. This is where you won't have a big difference between your high and your low tides. This is when you don't want to go to the beach, and this happens during your 3rd quarter and your 1st quarter moon. So, same logic that applies to when the high and low tides are also applies to the spring tides. Whenever they're in a 180-degree line, you have your spring tides. Whenever you have your 90-degree angle, you will have neap tides. Alright, you can kind of see in this diagram how the tides are changing whenever the moon is in different locations. And I think that is about it.